Alright, so we got video 1 of check yourself before you take that assessment. And so now we're talking about how to make a graph and checking for linearization and all that fun stuff. So here I have a data table, alright, and I recommend that you pause the video because your goal is to try and linearize this data, if necessary, as always, and walk away with a mathematical model based on this data. So if you can do that, you're awesome, you're all prepped and ready to go. Okay, so that's your challenge. Here's the data. On your mark, get set, go. If you have no idea what's going on, wait a few seconds, you can hit play, and I'll show you the next step. Alright, so best of luck to you. Alright, so if you're stuck, here you go. Step 1. You should have created a beautiful graph of area versus radius, and if you have no remembrance of how to create the graph, I got a video of that, so you want to check that out. But then you're going to look at this, and you get to this point, you should ask yourself, is that a curve or is that a line? Okay, so take that as your kind of next hint as to where to go. So hopefully that sets you on the right path. If not, wait a few more seconds, and you'll see my next hint. Okay. Based on what we saw from the previous graph, it was definitely not a line. It was a curve. Okay? We had points that start on one side of the line, they went to the other, then they came back from whence they came. So therefore, it was definitely a curve. So to fix it, we linearized it. So again, if you need help with linearization, we have that wonderful worksheet. I also have a video on that as well. And we had to square the x value, so we squared our radius. So what I did over here is I just did the mathematical operation. So here you can see how I took my radius and I simply squared it, and then I copied all the way down. And so then I made a new graph with that data. And as you can see, we have a beautiful straight line. Shocking. The r squared value is 1 because, like I said, I made up fake data. And so now we have an equation. All right. So hopefully from here you can get to figure out how to make a mathematical model. And if you need a little more guidance, I'll be back. Alright, if you're not sure how to create that mathematical model, then you can kind of follow along with me as I create a wonderful mathematical model over here. Let me get my pens all set up. So remember, this is a straight line, so we're going to be living and dying by the equation y equals mx plus b. So we ask ourselves a series of questions. Alright, what's on the y-axis? We got area. What's on the slope? That's our m. So our slope here is 3.14. 2. Never forget units. So slope is y over x, change in y over change in x. So we have meters squared divided by x values of meters squared. And then our x value is radius squared. And then finally, we have our b value, that's our y-intercept. And if you look, our y-intercept is 0.03. Since it's on the y-axis, we have to use the y-units. So that's meters squared. All right? So this is actually our final equation, except for one small little detail. Because this is meters squared divided by meters squared, they would technically cancel out. So that kind of goes away. So really our final equation would be area equals 3.142 times radius squared plus 0.03 meters squared. This would be your mathematical model that describes the data set that we talked about earlier. Hope that worked out for you. If not, come see me, watch some other vids. Have a good day.